Okay, so for example 3, we have log of x plus 1 base 3 minus log of x minus 6 base 3 equals log of 2x plus 2 base 3. All the bases are the same. I've got logs all over the place. So again, my two possibilities, either log equals log or log equals number. This looks like log equals log is where I want to go with this. All right, so again, kind of diagnose the problem to start off with. What structure do I want to make? And then I got to use my properties of logarithms to decide how to do that. So in this case, the logarithms here are being subtracted, and our property of logarithms says when logs are being subtracted, we're going to divide first by second argument. So the left-hand side, this entire side here, can be transformed into a single log expression, log of x plus 1 over x minus 6 base 3, using our property of logarithms to transform a expanded logarithm into a single logarithmic expression. That's going to continue to equal the right-hand side, which is a single logarithmic expression. The right-hand side is kind of behaving itself right now, so I'm going to keep it as is. Okay. And again, that's one of my two places I can get to that I can work with the problem. Either log 1 equals log 2, or log 1 equals a number. So if the logs are equal to each other and the bases are the same base, which they will be, they're not going to give you some problem with different bases probably. Then once you have the same base logarithms, the arguments are equal to each other. So either, so not either, but exactly, x plus 1 over x minus 6 must equal 2x plus 2. Now when you have a subtracted logarithm to create this fraction structure, you quite often get this kind of look. A fraction equals something. Maybe fraction equals fraction, fraction equals a whole number structure. My advice is, whether it's a fraction equals fraction or not, make the second one look like a fraction. You always have a single log equals a single log. Typically you have just a simple argument, a simple argument. So if you do have a fraction, it's all by itself, all by itself. It creates a proportion, so we can cross multiply to simplify. So I'm going to multiply x plus 1 times 1, and I'm going to multiply x minus 6 times 2x plus 2. Now each of these algebraic pieces, x plus 1, x minus 6, and 2x plus 2, are all binomial structures. So when I'm multiplying, I have to follow the rules of algebra in the simplification. So 1 times x plus 1 I would distribute. So I'm going to get 1 times x is x, 1 times 1 is plus 1. Over here I have a binomial times a binomial, so I'm going to FOIL that side. First times first is 2x squared. Outside times outside is going to be positive 2x. Inside times inside is going to be negative 12x. And last times last is going to be negative 12. So in simplifying this structure, it creates a quadratic structure again. The quadratic term happens to be on the right-hand side. I want everything on the same side as the quadratic term. The quadratic term is positive, so I'm going to keep it where it's at. So I'm going to move the x and the 1 over here. So I'm going to chop this positive x, make a minus x. Chop this positive 1, make a minus 1. And you can see altogether we have 0 equals. I have a 2x squared. That's the only x squared object. All three of these guys are x's, right? So 2x minus 1x minus 12x makes minus 11x. And then minus 12 minus 1 makes minus 13. This one in particular has a coefficient of 2 in front of the x squared, so the simple type of factoring that we've done in the last couple of problems doesn't happen here. I can't find numbers to multiply to make that, but I had to make that. So instead, I'm going to use the quadratic formula on this one. So quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. For the given function up here, a is equal to positive 2, b is equal to negative 11, c is equal to negative 13. The signs are attached to the numbers. They do matter and they must be considered. The three pieces I have to create down here are minus b, so minus b is going to equal what? Positive 11, right? b is negative 11, so minus b means change the sign of b, negative 11. 2 times a just means 2 times whatever a is. A happens to equal 2, so 2 times 2 is 4. And then b squared minus 4ac. B squared, no matter what b is, positive or negative, is going to be positive. So 11 squared is 121 minus 4 times a, which is 2, times c, which is negative 13. This product happens next. And it always is minus. It says minus 4ac always. But that minus can become a plus if the product makes it happen. So 2 negatives in the product makes it become plus. 4 times 2 is 8 times 13 is 104. So if I add 121 and 104, I get 225. So b squared minus 4ac is 225. So again, I want to evaluate those 3 pieces, and then I'm going to stick them all into the quadratic formula at once. So if I create my structure here, x equals that structure, I'm going to put minus b right here, which is positive 11. B squared minus 4ac under the radical, which is 225. And 2a on the bottom, which equals 4. So again, figure out the 3 values and then just stick them all into the formula at once. That's the easiest way to do the quadratic formula. Okay. Hopefully we all know the square root of 225 is 15. So we're going to get 2 answers, both over 4. And we have the top, which is plus or minus, creating 2 different answers. They're both over 4. So 11 plus 15 is 26 over 4. 11 minus 15 is negative 4 over 4. So my answers are x equals 13 over 2, comma, negative 1. As before, I have a logarithmic equation. The rules of logarithms require that every argument in the original problem is positive. So I'm testing the arguments with the answers. For the sake of simplification, I'm going to make this 6.5 when I'm evaluating. 13 halves is 6.5. So if I'm testing x equals 6.5 here, here, and here. 6.5 plus 1 is positive. Specifically positive 7.5. Again, the number doesn't matter, only positive matters. 6.5 minus 6 is positive. 6.5 times 2, 13 plus 2 is positive. So everything's positive with 6.5, so 6.5 is a perfectly fine answer. My other answer I'm testing is x equals negative 1. Negative 1 plus 1 is 0. That's illegal. It has to be positive. 0 is illegal. Negative is illegal. Even if that was legal, negative 1 minus 6 is negative 7. Now it's negative, right? So this answer is no good. This answer is good. So we throw out the negative 1. X equals 13 halves is the right answer. Expect quadratic functions to happen quite a bit in this assignment. Again, if it's 1x squared, factoring is probably going to be useful. If the answers are not rational, for example, if the answer is 1 plus or minus the square root of 17 over 5, that won't be factorable. The quadratic formula will have to be used in that scenario. So do use the quadratic formula a few times, even if you don't necessarily have to, just to practice it and get better at it. And again, they're going to happen quite often. You're going to typically get, if you go to quadratic, you're going to get 2 answers. Usually one of them works, one doesn't, but they're allowed to both work. They can do that, but it's not common for them both to work.